In this video, we are going to look primarily at the coincident sketch constraint. That is the first one right up here in the top left corner of the constraint symbols, and see what it says about itself. Constrains points to other geometries in 2D and 3D sketches. We're going to stay in 2D sketch for this video, but these principles apply as well to 3D. Let's start by drawing a few lines. Draw horizontal, vertical, horizontal, and I'm going to draw one more vertical line, and notice I left that corner open on purpose. As you draw in Autodesk Inventor, if you're drawing lines, point-to-point clicking, see what happens as you draw. Look at this corner right here. If I click and drag on this corner, these two lines move with it. If I move this line up and down, this endpoint follows. If I move this line left and right, the other endpoint follows. And that is because as you draw point to point, line to line in Inventor, it automatically applies coincident constraints for you. Coincident simply means that one point is sitting on top of another point or some other geometry. See this green dot that pops up in my color scheme? That is the endpoint of the line. If I click on this line, I have a perpendicular constraint that pops up there. It constrained those perpendicular as I drew. Let's move that aside, move the mouse cursor over that little yellow dot, and we get these two coincident constraint glyphs or symbols that pop up around the endpoint of that line. Notice there are two of them here because I have one for each line. Each line has an endpoint. They are constrained here together. So that means I have both of them. I delete one, that deletes that pair. They always come in pairs. You can see here the perpendicular constraint, this line and this line, they are a pair that tell these two lines are perpendicular to each other. But when we are using coincident, they are in the same place, so we see them right there side by side. Deleting one deletes the other. So that's the first thing you need to recognize, is that coincident constraints are created all the time as you draw, and you don't have to apply all of them manually yourself. Let's start another line. If I start a line, if I come here to this corner, see now it's going to kind of stick to that corner. It pops up with the green dot, and that little symbol that pops up in that little window tells me I'm putting this on the endpoint. If I come down here, see it's telling me I'm sticking this point to a line. These are all just kind of different versions of a coincident constraint. It's just telling me where it's going. So endpoint, sticking somewhere to that line. Let's start another line. If I slide down this line till I get that green dot, I see how that little symbol changes. It tells me that is the midpoint of that line. So no matter what, this line sticks to the midpoint. See, as I shrink this down, different things happen just depending on where I click and drag. Let's get rid of that one, but we can see that this horizontal line always sticks to the midpoint of that vertical line. Let's draw something else. Let's draw a circle. I can use a circle because a circle, let's just draw one out here. A circle has a center point. That is a point that I can constrain to an endpoint of a line, whether I use the coincident button directly, or if I just start sketching my circles, I can put the center point of that circle on a line. I can put the center point of that circle on an endpoint of a line, so it will stay on that endpoint. See, this one's free to move up and down. This one is stuck to the endpoint. I can click and drag geometry that's already there. Watch what happens when I get down to that corner. Now the center point of that circle is stuck to that endpoint. Let's draw an arc. I can draw an arc that starts on an endpoint. See, as I position it, I do get a tangent constraint that appears there as well. But I draw that arc, one endpoint stuck to that line. If I drag this one, drop it on here, Now I have another coincident constraint as well. Inventor helps us out as we draw, and anytime that we want something to stick together, as long as we're close enough when we start, then those things will stick. Very common use. Let's clean this up. Let's get rid of all this mess. Except for that original rectangle that I drew. One thing that you'll probably run into pretty often is that you sketched some shape and then you get out here and you realize you didn't stick those last two endpoints together. If you notice that, or if you had some other geometry out here, say you thought you were going to draw something else, but then you decide you need to delete something, you can just come in, use coincident to close that box, because to create an extrusion, you have to have a closed profile. Let's back up. Let's get back to that point. Finish that sketch. Try to extrude and see what happens. It's offering to create a surface just off of those lines. But if I am trying to extrude a solid, I have to have it closed. And the coincident constraint will help you, save you, when your sketch is not closed. Let's go ahead and finish out this sketch because we need it to be fully constrained if we're going to draw a good part. Let's make that 3 inches. Let's make that 2 inches. Now we have a rectangle. Let's take a look at what we've got. We have a rectangle that is going to stay 3 inches by 2 inches no matter what, but it still tells me I have 2 dimensions needed because I can move this rectangle all over the place. A quick way to finish out this sketch: apply a coincident constraint from a corner or from a midpoint to the origin. I like to have my rectangles, when I start drawing a part, centered around the origin. There's a couple of ways we can make that happen. But let's draw a line. Make it construction geometry because I don't need it to be part of my part. If I draw a diagonal line corner to corner, then apply a coincident constraint from that midpoint to the origin, now I have a fully constrained sketch. The midpoint of that diagonal line is stuck to the origin. Let's finish this sketch. We're going to create a little extrusion here. It was stuck in surface mode. Turn surface mode off. I'll get back to solid mode. Let's just make a little plate 1/4 inch thick. Now let's start working on this part to see a few more ways that the coincident constraint can help us. See what happens since I drew that original rectangle around the origin. Now I have a point I can work with right in the center of this part. Now let's draw a circle. As we said, the center point of a circle is a point that we can use to constrain. So I'm going to bring that center point, start it on this origin. Let's just make a 1 inch circle right there. Finish that sketch. Create an extrusion. Let's use it to cut through all. What does that do for me? Why would I draw it that way instead of adding dimensions? That just makes it really easy that if I ever come back here, change this original rectangle, that circle stays stuck to the center of that rectangle that I drew. It stays constrained to the origin. Let's draw a little bit more on here. Let's start another sketch, see some more ways that we can use coincident constraints. Let's draw a rectangle. I'm going to use this time the 2-point center rectangle. Let's make it construction geometry because I don't want to extrude a rectangle. I'm going to put the center point of this rectangle, again giving me a coincident constraint. I'm going to put it right on the center point of the circle, which is the origin of my sketch. Let's apply some dimensions up here. Let's make it 250 from the top, 1/2 inch, 500 from the side. And I put this here so that I can create some points. If we click on point here, that is giving us a center point, because I want to turn this into some holes. Make sure that this button right here is turned on. That gives us a center point, which is what the hole feature will look for to create centers. And now as I go along and click, let's say I missed that one. So as I click, if I hit that point, I get my coincident constraint. This one, I wanted it down here on that corner and I missed. I can either drag and drop it. Now it is constrained to that point. Hit undo just to show again I can use the coincident constraint to apply the constraint there as well. Either way works. Either way is fine. Inventor does a lot to help you out and apply those constraints as you go. Let's finish this sketch. Make a hole feature here. Let's just make it a... Let's make it a 1/4 inch hole. So now if I need to go back in here and edit this sketch, let's change that dimension. Maybe I want that to be 375. Having these points constrained to that rectangle gives me a quick way and a good visual of how all these things are lined up. Makes it easy to change the numbers, and everything adjusts and adapts quickly and easily, repositioning those holes around that center. Let's do one more thing. I'll create a new sketch on this surface. Maybe I need to come in here and cut out part of this circle. If I start drawing a line here, I can do the same thing that we did before. We're starting a line on an existing edge will create a coincident constraint as well. Suppose I didn't hit that one. Maybe I overshot. Maybe I missed. I can still come in here, apply a coincident constraint to stick to that edge. So now this cutout that I have up here, oops, jumped. Sometimes things jump when you don't have them properly constrained. But this will move and stay stuck to that edge. Let's apply a couple more constraints. Let's make that 1 inch wide. I'm going to throw in a vertical constraint to put the midpoint of this line directly over the center. And that leaves me with just one more dimension to apply. Let's say that is 1/8 inch. Now that sketch is fully constrained. And make that cut through. So as you can see, the coincident constraint is a very powerful little tool. Everything you do, everything you sketch is going to have the coincident constraint in it somewhere. Even just drawing a simple little rectangle is going to be full of coincident constraints. So practice using this constraint. Practice deleting the constraint. Click on the line, see the constraints that are on it, so you can delete them. So you can go back and reapply them. See all the different ways that you can use a coincident constraint, whether you're applying it directly or it is being applied for you as you draw. When you are ready for the next constraint, which will be the collinear constraint, is a good follow-up to coincident. When you're ready for that, you can click on this next video right here. Thanks for watching. Have a great day.